orientated paradigm. What do we call it when it's shortened down? OOP. Exactly right. Can anyone remember just briefly off the top of their heads, what the hell is OOP? What is the idea of OOP programming?
It's where you separate code into objects or comparatively to real life objects.
Absolutely spot on. And each one of these objects, guys and gals, has got its data and its code. And it sort of lives by itself. So I gave you the example of a computer, so I'm going to quickly revisit that one and we'll move on with our lives because we've got very little theory to finish with. But when we talked about the idea of building a computer, we have discrete parts inside a computer of our RAM, our CPU, our hard drive, our graphics card, and all that plugs into the motherboard. And each part has got its own job to do, doesn't it? So the CPU does the thinking, the hard drive does the storing or remembering, the power supply does all the power feeding, and if one of those breaks, then what do, Dobby? You replace it. You get a new one. So this is the idea of OOP programming. Everything is its own section, and it sort of lives by itself, but when you put them all together, magic happens. And if anything breaks or it needs fixing, you only have to fix it or replace that one thing. And then we briefly talked about, what we have been doing on the right-hand side in our Hangman game, where you just added hundreds of lines of code to try and get what you had working. And that's great for small programs, but when you start getting bigger and more complex, you need to go a different direction. You have to go for something like OOP or something different. Flicking through, guys, we then quickly talked about 3 or 4 concepts from memory. Top down and bottom up. Top down being you got the big idea and then you break it down in small pieces, or bottom up, you start with the small pieces and it builds up into the big idea. We're actually going to do a bit of bottom up very soon when we do our programming. Then we had the facade pattern. Does anyone remember the facade pattern? Briefly, what do you reckon?
Finding a bunch of code into one function or both.
Exactly right. Something really simple, but actually in the background, holy crap, it's really complex. Think about like a language. How many of you have used Chat GPT at this point? Come on, you've all used it, haven't you? Or image generation. Yeah, exactly. You've used it, Mr. Well, haven't you? Yeah, for that last English assessment you did. Yeah, exactly. The idea, like a large language model, they actually have like gigabytes, sometimes like terabytes worth of data in the background. And when you type in, give me some names of dogs, and you hit enter, it's actually doing thousands, sometimes millions of operations in the background, but it was literally a single button click for you. And that's the facade pattern, just keeping it nice and simple. Agility, who can quickly touch on that one? Who wants to give it? Tell me, what's the agility?
Agility is the ability for program to adapt to changing needs of the client.
Example? Absolutely perfect, yeah. When GST came in, all accounting software around Australia crapped the bed and they all had to go and change their code to include GST. Okay, and if you are working in an OOP model, the object-orientated, it actually makes things a lot easier because you could just take out one part of your program and go, all right, GST, you're coming in. Simple as that. All right, so guys and girls, the first thing we are going to do today is I would like you to consider our good old fun with flowers. Remember that thing I said, leave 4 or 5 pages and then we did like 1 in your books? Yeah, we're going to revisit it. I want you guys to think about this program. And in your best efforts, I would like you to break it down into modules. And I've got an example answer in a second that we'll go through together. But a local florist, Fun with Flowers, is expanding and looking to introduce an app where customers can make orders. This app will feature a catalog, shopping cart, they should say cart, I still haven't fixed it, ability to make orders and add personalized messages to those orders. What I'd like you guys to do is draw something that looks a little bit like this. So at the tippity top, you're going to have Fun with Flowers. And underneath that, you're going to have each feature for our Fun with Flowers app. And then if you can break that down even further into tiny little itty bitty pieces, I'd like you to have a go at that, guys. So I'm going to give you 5 minutes to just quickly jump in and have a go. Oh, there it is just there. So I broke it primarily down to catalog and user. So I've gone, the catalog has the items for sale, and an item is made up of the name, the price, and the type on the left-hand side. Then the user side, this is obviously where I put the shopping cart, the items, and the message. So you guys were pretty much on board with what I was thinking with the shopping cart. And for the user, there's their personal details. Now what's going on here? What's this arrow doing? Exactly right. Because you're not going to have 2 giant sets of items, are you? You can have one giant set of items for the catalog, and those, the ones in your shopping cart, come from the catalog. That's what that little arrow there is doing. All right, so everybody, I've got a challenge for every single person in this room. I want you to try another one. So a local bike shop, fun with pedals this time. Can't you see how inventive I am with my naming? It's fantastic. They've requested a new app where users can purchase bikes, books, services. So book services in, I want to oil my chains, pump up my tires, fix something on my bike, and request advice. So guys and gals, can you try and do one of those little diagrams for fun with pedals as best you can? 5 minutes. All right, guys and gals, can I steal you away from your lovely books and your notes for a second? Let's have a think about this one. So I'm going to be very lazy. We're just going to put FWP, fun with pedals, okay? And we're going to break it down a little bit. So Adrian, what did you put here on the left?
The bikes.
Oh, yep, cool. So this is like our bikes catalog or whatever like that. That's great. How did you break that down any further? Because there's a lot to do with bikes, isn't there?
Yeah.
Yep. So where'd you go from there?
Just went for bikes for sale.
Yep. So sale. Nice. Anything else?
And
No, that's okay. I'm not I'm not expecting more answers. I'm seeing what you've got there. So one thing you could do, I reckon, is you could have like a breakdown of their details.
oh, like name, type.
Yeah. Like literally you could have name, then their type. Somebody else who knows more about bikes. What else can we put? Gears? Oh, that's a really complex, but I'll put price there, yeah. Rating. Oh, yeah. Rating. Very nice. We're starting to think about a real app now. Anything else we could put? Reviews. Yes. So I could actually turn this into something, but let's go over here. Reviews. All right. A description would be really good. I'm running out of space. Description. You guys are just trying to feed me stuff, so I'm running out of space, aren't you? I know your tactics. All right, I'm stopping there. All right, we've got our bikes. What else can we do in our fun with pedals app? We reckon, Harry, what's another section? Support. Love it. Support. How can we break the support down, do you think, boys and girls? Chuck it in there, Val. Ooh, FAQs. And direct. I love it. So it could be a chat, a phone, a message, anything like that. That's really good. Did anybody add anything else underneath the fun with pedals that they reckon I should include, Zach? The user. That'd be a really good one. What about the user, Zach? Ooh, okay, info. Now I'm going to cheat here because I'm just going to put lots of dots. You guys know that you should put lots of info like names and address and all that kind of stuff, yeah? Awesome. What's some data from a user we should never store? Card details, spot on. Yep. There is a lot, but card details is the number one. Never store credit card details, please. Anything else you put under the user, Zach? Aside from info? If not, that's okay. I'm just seeing if you've got anything. Ooh, we could do the cart. Yep. Because we're going to buy stuff through this app as well. Okay. I'm going to stop there because this is really good. A tiny little app like Fun with Bikes, or Fun with Pedals in this case, can break down that far. Imagine if you have a gigantic like banking app. Imagine how far you'd go with that. Now, guys and gals, I want to remind you too, this is not an official diagram. I'm just getting you to think about that top-down perspective of starting with a big problem and breaking it into pieces. Now, I promised you guys and gals that we would just do the main theory, get that done with and work on to prac. And we are about to do that. We've got 3 more slides and there's probably about 10 minutes worth of writing here. So stay with me for a bit. The first thing I want to quickly talk about is why the hell would you use OOP? Okay. And there are 4 very clear reasons why you would use OOP. Nice job there, Adrian. The first one is collaboration. Okay. Imagine you are working with someone else on the Fun with Pedals for a second. Harry and I are collaborating. We are working together to make this app. It's going to be the best app ever. We're going to make $1 million out of it. Harry's going to focus on the bike section and I'm going to focus on the user section. And the really good thing about OOP is because they're completely separate things, we can work in separate files, which means we can code to our heart's content all day long without impacting on each other's code. So Harry can go crazy with the bikes and I can go crazy with the user. and we never clash because we're not working on the same thing. So that is one amazing thing, is it just enables this collaboration because all the files are separate, all the logic is separate as well. The second thing is everything is really organized because we're broken down into these objects, and each object has got its code and its data to itself. It makes our thing so much cleaner. I'm about to show you how you guys can draw graphics on the screen using a lovely little guy called Turtle, which you might remember from last year. Maybe. Ben's nodding. Very nice. You're going to be able to draw really complex shapes in like 3-4 lines of code. And that's because it's really clean to use OOP. Next one, it's easy to debug. If we know there is an issue with the user details in our Fun with Pedals program, we know where to find it, don't we? You go down the user section, you go, oh, there's an issue with the cart, you go down the cart section, and you find exactly where the bug is. Okay, usually that's where the bug is going to be. And it creates better testing because we can test all these little boxes by themselves. And then when we put them all together, we'll test them together, and then we start putting more together. And eventually the jigsaw finishes and we've got Fun with Pedals. So these are 4 main benefits for OOP. What do you reckon's a drawback? I would tell you now the drawback is things are a little bit more complex because there's lots of files. You can get to a point where you've got thousands of files in a project, and it sometimes can be a little bit unwieldy, especially if you're joining halfway through a project. That becomes huge. All right, guys and gals, you ready for this? Onslaught of terminology for you. Glossary time. All right, what I'd like you to do, rather than me just go through this, I would like you guys to actually write down these terms. There are 1, 2, 3, 4, 5, 6, 7. Once you've written them down, we're going to revisit and I'll talk about each of them. Okay? Thanks, man. All right. So guys and gals, there are 7 core concepts of OOP that I really want you to take away from today. And I'm going to try my hardest to explain them with an example. And if it still doesn't make sense, I want you guys to say, no idea, and we'll try again, okay? I'm happy to try again and again and again. But the first concept is called a class. Remember when we were breaking Fun with Pedals down into those boxes? Each one of those boxes is a class. It's a way of organizing your data and your code together. Now, when we get into this topic, we're not going to call them data and code anymore. Data becomes attributes, and then code becomes methods. Okay, think of it like the attribute of Chloe is that she's got brown curly hair. What color are your eyes there, Chloe? I don't even know. Blue, okay, and etc., etc. And then methods of is I'm assuming she's able to read, write, eat breakfast, those kind of things. Okay, they're the actions she can perform. Now, let's go a bit more coding concept for you guys and girls. Yeah, let's imagine I made a class called shape, and in that class I write all the code that's going to handle where is it drawn on the screen, what's its position on the screen, what's its color, and what is its size. And it can also, as a part of its actions or methods, it can calculate its own area and its own perimeter. Sound okay? No, we don't like that one. So it's the idea of a shape, and that shape can have a color, a position, a size, and then it can calculate some, stats for us. So that's just in that one little class. Now, here's the bit that confuses a lot of people when they first start learning OOP, is that when you create a class, you've then got a thing called an object. Okay? Let's say I've got this shape class, and I really want to make a rectangle. Okay? The rectangle is the object, but then I want to make a triangle. The triangle is an object as well. And then a square is an object. When you create something that uses the class, the shape class, it's known as an object. Okay? So in this example, I've said a rectangle that's position 0, 0 is 100 by 50 in size and it's blue. That's an object. And if I make another shape, and that's also a rectangle, that position 10, 10, that's 50 by 50, which would be a square, I know, and it's red. That's an object as well. And then I can make another rectangle and another rectangle and another rectangle. Okay, that's the idea of an object, is you have one class and you can make as many objects as you want. Have a look at this room. I could make a class of a student, and then I can have an object, which is Adrian, another object that's Will, another object that is Dobby, another object that's Zach, for every single person in the room. Does that make a little bit of sense for you, year 11? Somewhat? No? Okay. The next one, encapsulation is just a term we use to say all of our data and all of our code is together in a single thing. Okay, that's why I drew the little tablet, because there's stuff inside of it. But essentially, it's just trying to separate your code into one little container. An abstraction is the idea that we're hiding that code and that data from people who use it. Okay, we don't want people to be able to change it. We don't want people to be able to stuff around with their code, but we'd love them to be able to use it. Okay, and that's the idea of abstraction. Hide it from the user. Keep it simple. All right, as simple as that. And then 3 more concepts which are a lot more complex, but stay with me. Inheritance. Let's say I've got my shape class. Remember, it's got a color and a size. It can calculate area and perimeter, right? What if I want to introduce a circle? It's very different to a rectangle, isn't it? But it still has a size, it's got a color, it's got a position, but I want to add new functions to this. So what I do is I inherit all the code from shape, and I make a brand new class called circle. And I can add custom code to that circle. Information about radius, information about calculating diameter, all that kind of stuff. All right, generalization's a bit weird. Imagine we created lots of different classes. We created a triangle, a circle, a rectangle, a square, all that kind of stuff. And we added the ability to draw those shapes on the screen. We went, holy crap, that's really useful. Let's put it in our original shape class. That's generalization, is the idea that we're adding a function to every single class, and we go, nope, let's add it to the parent so everybody gets it. All right, and then the last one, polymorphism, is probably the weirdest sounding one in the world. But you've actually used it since day one, boys and girls. The print function is a polymorphic function. How's that for a terminology quick? Polymorphism is the idea that I can use a function and I can send it a string and it will do a job. I can then send it an integer and it will do a job. I can send it a float and it will do a job. I can send it a Boolean. So it basically reacts to every data type I throw at it. So if I print hello world, Val, what's it going to do?
It's going to print the string hello world.
Beautiful. Then technically it's not a string, isn't it? So you're right. All right. But Dobby, what if I send print the word false? What's it going to do? It just prints the word false. What if I put print 3.14? What do you reckon, Brody? What's it going to do? And that's why the print function is polymorphic, because it can accept any data type and it still does its job perfectly fine. Okay, and we can do that with classes as well. But they're all the terminology, everybody. What I'd like you to do, if you haven't already, finish writing up those notes, please. I know, long class. And then jump into exercise 2.1, which, to help you out today, guys, is just a quiz. And that is it. Once you've done that, once you're happy with your mark, can you jump into 2.2 and have a look at those slides? All right, thanks, guys.